In this video, I'm going to show you how to draw drainage basins. We're going to start with figure 1029. So I'm going to go ahead and zoom in here. Now, just looking at this, we can see that we're looking at contours that go from 120 or 1025 to 1075. This is 1025. And down here is like 975. So that's 975, 1025, 1075. Now, when I'm looking at the drainage basins, what we're doing is we are looking at high points. So this is 111.16, 1054 is over here. So what I want to do is I'm going to set and I'm going to start going, okay, here's my point of discharge. So I can actually see, remember, when the contours are pointing uphill, it's actually a channel. When the contours are pointing as a V downhill, that's going to be a ridge line. So something specific that I want y'all to take a look over here is this side of the roadway, this Washington roadway, is actually going to be a break line. So this is a little bit blurry. You can see the contours. They're not as clean as I would like them to be. So I'm going to go ahead and show you the finished example so I can explain how to do it. And you can draw it over the top of yours so you can see it also. So I'm going to pull this side by side. So as I'm drawing the contours, you can see what I'm doing. So let me make this a little bit smaller. Let's bring this over. And I'm doing this in CAD because I want to be able to get the area. Now, these are just examples to get you all comfortable with drawing the basin maps. So I'm going to go ahead and close this out to give myself more room. I'll pull this down. I'm having a bit of a problem. All right, so I collapsed that. Now I'm going to start to draw. So if I take a look at this, let's take a look at this plan right here first. Notice how it comes up this way, okay? We're actually we're assuming that this channel, and you can tell that it's a channel by the line and 3 dots. Usually that's the universal for civil engineers mostly to tell you that's some type of a ditch, discharging, or a swale or a stream. Notice I've got one tributary, another name for a stream, another tributary tying into the confluence going down. So we've got a lot of little streams discharging to this point of analysis, our discharge point, or our outlet. So since all of this falls to this one point, we know that it has to drain this way. Now, why does it break it here? It's because this contour is shaped like this. And notice again, we're going perpendicular. So I'm going to come over here and I'm going to draw this. So I'm going to go polyline and I'm going to start drawing it like it shows here. Okay. I'm going to make that a little bit smaller. Notice how it keeps going upstream. Anything on this side of it drains, and we're always running perpendicular to our contours. So I'm going to go ahead and come back over to my drawing, and I am going to continue to go up here. Remember, when the contours are pointing downhill like this, then that's going to be a ridge line. Okay, so I'm going to come up here. And I'm going to say, okay. And again, if I had better contours, then I would be a little more conservative with making sure that I'm going perpendicular to these. For the most part, I'm getting close. I'm going to go undo. I'm going to bring this over. Undo that one more time. Bring this over here. Okay, now notice that they guess in here. This is a true guess. You would need to have more contours, or you need to do a field site visit. But they've got it coming through here like this. And sometimes we'll use statistical, like a triangulated network for these. Now, the next thing it does is got a flat area here. So anything on this side goes and drains down this direction. I'm going to come back out here, and I'm going to bring it through here. And I'm going to come through this saddle. Now, I know this is another ridge line, so I have to be particular on how I bring this through. Again, going perpendicular. Coming through here. Now, normally, if this point here that lists at 1116.8, most of the time I would assume that's the absolute high point that they came up with. But this drawing shows it going through it. I'm going to go through this way, and then I'm going to start to bring it down like this. And they've got a little bit smoother drawing than I do. Their lines are a little bit smoother. Over here, bring this down. Oops. Now, you could probably pick one or the other side here to come around like this. You're still wanting to go, I'm going to undo that, between these two. And on this one, it shows how it goes through that X. Like I said, I would normally, if a topographic map only has one point, I would assume that that's the high point that's going through. Coming through here. Now, you've got multiple things. You would need to know, like you could have picked coming down through here, okay? But this one has it coming out over here because they're assuming that there's something that's bringing this ditch line into it. Now, you would actually have to have a little bit of knowledge of the site to be able to assume that. Now, take a look at these contours. See how these are wrapping arced like this? Okay, that tells me that this is an ultimate ridge line. That roadway is a ridge line. The same as this one. This one's breaking where if you were looking at the elevations, and you can see them a little bit better on this side, you could see that this contour here breaks here, so this will flow this direction, and here flows this direction, but it has to hit and then roll down. That's what this is saying. They're saying that the Washington Avenue is a ridge line. Now that's not always true, but we're going to assume that is here. Okay. Now, why do they break it through here? Now the reason they break it through here is because they've got this pond here, and that would be a secondary point. But take a look. You've got, again, this area pointing downward. So that means I've got a ridge here that once water hits here, it rolls that way. If water hits on this side, on basically the bottom left side, it's going to roll down to that pond. So that's why we're putting this in here like this. So I'm going to continue on following the road. Typically when we do these, we have a lot better contours. We would actually have a topographic survey, not a USGS map. Again, it's easier to see these little scallop things. That means it's vegetation. Okay, so bring this down. But in this drawing, it is a little hesitant. That's why I'm kind of helping you out with these drawings this week. Bring this over. Following this path down. Also, U is for undo, or you can use the undo button up here. And then CL for close. Now what I'm going to do is I'm going to bring my properties palette back up. I'm going to click on that line. And that's going to tell me the area. So I'll just make that a little bit bigger so you can see it. So that's my drainage area. And I'll click on the button next to area. If not, remember this is in square feet. And pull this up. I'm going to go unit conversions, pull this down. And I'm going to say area from square feet to acres. So this is 5.5 acres based on this. Okay, so I'll show you how to do the next one in the next video.